Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So this is another lecture from the Strivers A to Z DSA course. Just in case you're for the first time here, this is world's most in-depth course when we talk about DS Algo. Why do I say that? This course has 455 modules. By the end of the course, you would have solved more than 400 plus problems when it comes to DS Algo. You can go over the entire internet. You can buy any of the paid courses. None of them will be teaching you DS Algo in such depth. Something that I can give you as assurance is once you cover up the entire course, you'll be able to clear any of the DS algorithms in any of the companies in any part of the world. So till now, I have covered up till this particular problem. Now in this video, I'll be covering up the problem merge overlapping sub intervals. So what does the problem state? It states that you will be given an array of n sub intervals. Now what is the definition of sub interval? If you're given 1, 3, it means it starts at 1, it ends at 3. That is a particular sub interval. Now your task is to merge all the overlapping sub-intervals into one and find me out how many minimum intervals you can give me. So if I have to understand overlapping, let me give you an example. So if I take this 1, 3 and I can say this one starts at here and goes till here. If I take this 2, 6, I can say it goes from 2 to 6 till here, right? If I take probably 8 and 9, I can say 8 and 9 is this much. Wow, that's a longer one. So 8 and 9 is this much. If I take 9 and 11, I can say 9 is from here and 11 is still here. Perfect. If I take 8 and 10, so it can be like 8 and 10, right? If I take 2 and 4, it will be like 2 till here, 4, correct? If I take 15 and 18, it will be 15 till 18. If I take 16 and 17, 16 and 17, understood? So I've drawn all the intervals. If you see, all the 3 intervals can actually be written as into 1 and can be written as 1, 6 because if you take 1 and 6, you will be able to have all the overlapping intervals into 1, right? So that is why 1, 6. If you look at over here, that's like 8 to 11 and you get all of them into a single one. If you look at over here, it's 15 to 18 and if you take 15 to 18, you get all of them into one. Now you might ask, why not take 1 to 18 and you will have everything? In that case, you will be having a lot of empty places. So when you talk about 1 to 6, 1, 2, 3, 4, 5, 6, each of the coordinates is being touched by someone. If you see, is being touched by someone. So one of the intervals has to touch it. So that is why I have to find the minimum possible intervals that you can club them into. And for this particular example, this will be the answer. So it will be shrinked into 3 possible sub-intervals after you have merged all the overlapping ones. So this is what you have to return me. Yes, merge them and return me the number of sub-intervals that they can be merged into. So this problem comes up in an interview. What is the first brute force solution that comes to your mind? If I can think of, it will be like, probably let's try to keep the intervals together. Like if you saw 1, 3, 2, 6 and 2, 4. If I can somewhere keep them together and clubbing them into one interval will be easier. So my first approach will be to club them together, right? Like to keep all the closer intervals together. So for the brute force, what I'll do is, the first step will be, let us sort them up. So if I sort them up, what I'll get is, probably first I'll get 1, 3. So when you sort pairs, at first it gets sorted by the first element. If at any moment, the first element is equal, like for this and this, the first element is equal, then it will get sorted by the second element. Got it? So if I sort it, then 2, 4 will come in, then 2, 6, then 8, 9, then 8, 10, then 9, 11, then 15, 18, and then 16, 17. Perfect. I've written down each of the pairs in the sorted order. Next, what you will do is, you will basically start iterating over and you will be at 1, 3. Let's stand at 1, 3 and say that is my possible interval. Just hypothetically say, this is my possible interval. I'm like, okay. And now I'll do, I will go to the next interval. I'll be like 2 comma 4. Hey, 2 comma 4. Are you overlapping? How will you know is it is overlapping? Very simple. If it is 2 comma 4 and if you see the first element is before the last element. If the first element is before the last element, it is an overlapping. So I can say the 2 comma 4 is overlapping. So this 1 comma 3 will expand. Can I say in order to accumulate 2 comma 4, this will become 1 comma 4. Because if you take 1 comma 4, 2 comma 4 gets accumulated. Perfect. Next, I will try to move to 2 comma 6. Can I say 2 comma 6 is also overlapping? Why? Because the first is before the last. So overlapping. How will you accumulate it? Probably changing this to 6. If I change this to 6, can I accumulate the 2 comma 6? I can definitely accumulate. So fine. Let's go to the next. 8 comma 9. So we know one thing for sure. 8 comma 9 is not overlapping. Why? 8 is greater than 6. If it is greater, how will it overlap? So can I say I have got my overlapping things? Do I need to go ahead and check for this? No. Because if one is not, it is sorted. So anyone after it will never be stopped. So you got 1 comma 6. Okay. Next, move to the next. So when you move to the next, what happens? You have a 2 comma 4. And you see the 2 comma 4 is already there in the previous, like this was your previous interval that you got. It's already there. So if 2 comma 4 is already there, how do you know it's already there? Because the last element 4 is before 6. So it's already there. You don't need to do anything. Go ahead. 2 comma 6, it's already there. How do you know? The last element is before. So it's already there. Don't do anything. Move ahead. 8 comma 9. 8 comma 9, it's not here because the first element is out of this. It's not here. So you again consider this as one other interval and you start doing the same step. You stand here and you look at the other intervals. Who can be a part of you? You stand here and you look at the other intervals. Who can be a part of you? So you'll be like 8 comma 10. Can you be a part of me? He says, yes, I can because this is before this. So I will silently make it 10. Right? Then we'll move to 9 comma 11. Can you be a part of me? Yes, because 9 is before 10. I can. So I'll just silently make it 11 so that it is a part. Next, I'll move to 15 comma 18, which is out. I stop. And I get this as 8 comma 11. And next, I'll move to 8 comma 10. 8 comma 10 says, I'm already in, bro. Let's move. 9 comma 11 says, I'm already in. Okay, let's move. 15 comma 18 says, I'm not in. Please create a new one for me. He goes there and creates a new one for him. 15 comma 18. Perfect. And he stands here. He'll stand there and he'll look at the forwards. 16 comma 17. Can you be a part of me? He says, yes, because 16 is before 18. So I can overlap with you. So if I overlap, it is 17, but it's 18. It's already overlapping. Do you need to change 18? No. Please be careful. Do not change it if it is being accumulated. So do not change it. Done? Can I say the iteration for this is over? Next, move to 16 comma 17. It's already there. Over. So I got my answer. This is the extreme brute I can think of. What I did, first I took the 1 and I checked these two can be apart and I took them. And then I moved. And again I checked I have a new and then these two can be apart. So I took them. Then again I moved. And I saw this is a new and again I took them. So it's kind of standing at 1 and looking forward who can be a part of it. So I'm still looking forward. So we can improve it. But as of now, let's try to write the code for this one and then we can try to improve it. Got it? So let's quickly code this up again. You can find the problem link in the description. Probably I'll find the array.size. Perfect. Next, sort it. Quite simple. So I'll go ahead and sort it. Once I've sorted it, what is my next job? I know one thing for sure that I need to have this particular answer. So I'll have something which stores all the answers and I'll return it. And if you remember, we started iterating from here and we went on till the last. So we will go ahead and write a loop which starts from the first and goes till the last. Now what did we do? When we stood here, we probably considered this as the starting interval, right? That is what we did. So maybe I can take the start as array of I of 0 because it is storing list of list. And I can take the end as array of I of 1. But can you tell me one thing? When you started, you took 1, 3 and that 3 got replaced by 4 and then got replaced by 6. But what if you were at 2, 4? Did you do anything for 2, 4? No. Why? Because it was already a part of this. When you moved this pointer to 2, 4, it was already a part of 1, 6 that was computed. So you are like, hey, listen, if you have some previous interval, if you have some previous interval, which means you're not empty, and my end, I'm lying in you, that means 2, 4 lies in this interval. That means 4 is lesser than equal to the 6, right? So answer of back, if you do back, what happens is you get this. If you're standing here, you get 1, 6. And this is at the first index. The answer of back of 1, if you do this, you'll basically get whatever is the end of the last interval. And if this is the case, you're already lying inside it. Don't do anything. Go ahead. And if it is not, then this will be a part of your new interval. Imagine you're starting at 1, 3. Imagine you started at 1, 3. So you have considered the start to be 1 and end to be 3. Now what are you doing? You're starting at 2, 4, then you're going 2, 6, then you're checking 8, 9, right? So you have to go from the next. So you go from the next. Perfect. And what do? You basically say, hey, 2, 4, are you overlapping? Which means 2. Are you lesser than 3? Which means you're overlapping. So just write it. If array of j, the starting is lesser than whatever interval I've taken, lesser than this, that means it's lying. If it is lying, the end will get updated to max of end. Very important. If you've taken 1, 3, the 4 gets updated. The 6 gets updated. But at this case, when you're at 15, 18, even if the 16, 17 lies, 17 will not update. Thereby, please make sure you take the max. If you're greater, fine, I need to extend my range. Otherwise, I will not. And if this is not the case, I can say breakout. No need to check for any other. If that's not the case, breakout. Because if you're not lying, the previous elements will no more overlap. So just breakout. At the end, can I say the start and end will be updated to the new intervals? And that is what you can always store in your answers, like start, end. Perfect. That is what you'll store and that is what you can easily return. Now, I'll quickly go ahead and try to run it off and see if it is running fine. It is. So what about the time complexity? N log n for sure. So I can say n log n for sorting plus, how much is this? Might look like a big O of n square because you're running 2 loops, but it is not exactly big O of n square. Why? We're using something as break. We're also using something as continue. So you're actually saving a lot of time. If I go back to the test case that I took, if you remember, when you stood here, you just did for these 2 things and you expanded the interval to 1, 6 and you never went ahead. You just broke out after this. And then for this, you said it's already a part of it, so no need to check. It's already a part of it, no need to check. Then you went for 8, 9, then you checked for these things. So you're never going till the end, So what I can say is the time complexity, if I have to analyze it perfectly, let's analyze how many times do you do. So you traverse this one once, you traverse this element, then this, correct? Because for this, you went this, then you stopped. Now, what is the next thing you did? This moved to here, which means you traverse this once more. But this will say, I'm a part, so I stopped. Then this will say, I'm a part, so I'm stopped. Then you moved here, 8, 9. And then you again went for checking, checked, 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 and this is where you said no more apart, and you broke, correct? And then you again came here, and it is already apart. You again came here, it is already apart. Then you came here, and this guy went on to make the new interval, and it checked for this, and it got into it, and then it moved ahead and checked for this. If you carefully observe, every element is iterated twice. When you stand here, this, and then this, and then there's this. So kind of 2n. Can I say the complexity is big O of 2n? I can, because you're touching every element kind of twice in order to kind of shrink, rather merge the overlapping subintervals. So the complexity is big O of 2n plus n log n. What about the space complexity? It is big O of n. Imagine you're given an example like 1, 2, 3, 4, 6, 7. None of them is overlapping. So you end up storing everything in the answer array. So this will be your time and space complexity. Obviously, this is where the interviewer will not be happy with 2n. He will not be happy with 2n because you're still, for this element, you're still touching, you're going and checking. He's not happy. Why are you checking? Please reduce big O of n. This is where we move to the optimum. So what do we need to optimize? What are we doing currently? We're standing here and we're checking, can you be a part of me? And can you be a part of me? And he says no, so we stop. So we're kind of standing and we're checking who can be a part of me. That is what I have to avoid. So what I will do is, I'll try to do it in a single iteration. Let's see how. So we start off with 1, 3. And in our answer, we don't have anything. So we say, since we don't have anything, let's take this 1, 3 and we will move. And the moment we move, we have 2, 4. So if we have 2, 4, 2 is smaller than equal to 3. Overlapping. So I say, you're overlapping. Please come to me and get attached. And if it gets attached, I see it's 4. So I'll just increase myself to 4. Done. Next, I go to 2, 6. And 2, 6 says 2 is lesser than equal to 4. I am a part of you. Please increase your boundary to 6. And it does. Next, I move to 8, 9. 8, 9 says, hey, wait, I'm not a part of you because 8 is more than 6. I'm not a part of you. I'll form a new interval. I'm like, okay, form a new interval, 8, 9. I don't stop you. Please form. Next, move ahead. 8, 10. 8, 10. 8. It is 9. Yes, you're a part of me. Please increase. So go ahead and increase this to 10. Perfect. Move. 9, 11. 9, 11 says 9. Lesser than equal to 10. Yes, you're a part of me. Please take it and improve yourself. Perfect. Next. 15, 18. If I have a 15, 18, can I say it is not a part of this? Thereby a new. Just take it and store it into your answer. Next move. 16, 17. 16, 17 says, I'm inside you. But 17 is not greater than 18. No need to expand. I can stay with you. And it's so easy, isn't it? I just kept on checking with the previous interval item. That's it. That's how easy it was with a one pass iteration. Got it? Let's quickly code it up. So you can find out the problem link in the description. Please make sure that you try out the problem from the link in the description itself. So going back to the code editor, we will sort it. We will have an answer. We will return the answer. What in between? Something we saw was when we started, this was the first, we started with 1, 3. So we know one thing for sure. If we don't have any intervals till now, I can't compare. If I don't have anything, I can't compare 1, 3 with the previous. If it is empty or imagine you have 8, 9 and you had 1, 6. So the 8 was greater than 6. So it cannot be a part of it. Right? Then only you will form a new interval, because if it's the first time you form, or if it's not a part of it, then you form a new interval. Correct? So I'll be like, what am I currently at? Array of I, and is the starting. If that is greater than, because if it is not empty, then it goes to this answer.back which will be the last. So basically, if your array just has this, back will give 1, 6. And you do 1, it will give the 6. If it is greater, that means it's a new one. It's a new one. So you'll be like, okay, can I say then answer dot push back, and the answer, I'll have a new interval, and the new interval will be array of I, or maybe I can just push in the array of I. Yeah, perfect. I'll just go ahead and push in array of I, because that is what the current interval is. So I will end up pushing 8, 9 or maybe 1, 3 if it's empty. Done. What about the next? What if it is not? Yes. What if it is lying inside? If it is lying inside, let's go to this case. 2, 4. We had 1, 3. So I know this is lying inside this. So I'll take this 4 and I'll try to replace this. That's it. That's what I'll do. I will say answer dot back of your first, basically the last guy, will be max of answer dot back, whatever is your last element, comma my, which is array of I last. If I'm more, then I'll expand you. If I'm not more, I'll get into you. Simple. Once I've written this, I will end up returning this, and this will be running fine. Let's see if it runs. It does, and I'll quickly go ahead and try to submit it. So as you can see, hardly like 3 or 4 lines of code, and it does it for me. So what will be the time complexity and space complexity? Can I say n login for sorting and a single pass, because everything else is if else? What with the space? A big of n to store the answers. Imagine if all the intervals are unique and they don't overlap, so you'll end up storing everyone as its answer. So we have improved our time complexity, and this is where the interviewer will be super satisfied. So going back to the sheet, I can say that this one is done as well. I hope you've understood everything. Just in case you have, please do consider giving us that like, because it won't cost you anything, but it will highly motivate me to make such kind of content. And if you're new to our channel, what are you waiting for? Hit that subscribe button. And if you haven't followed me on Instagram, Twitter, LinkedIn, all the links will be in the description. With this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken.